All right, everybody, we're looking at the topic 11 and 12 review part two. This is also the review for your DCA. So, as we look at this question number one, it looks so much more complicated than it actually is. Okay, let me show you what I'm talking about. Okay, it's asking us to find the measure of angle C. And so what that means is this angle right in here. Okay, how big is this angle? A number of degrees. Okay, so let me highlight something that is going to be super helpful to notice for this problem. Okay, this right here is the only angle in the entire picture that's actually given. Okay, this angle right up in here is a 20-degree angle. Okay, if you will remember back and look in your notes in topic 12, we did a couple of theorems that were related to each other that basically said that the angle inside the circle is half of the arc. Okay, half of the arc, and what I mean by that is this arc right here that I'm highlighting in pink is twice as large. The measure of that arc is twice as much as the measure of that angle. Okay, so that means that what I just highlighted in pink, that right there, is a 40-degree arc. Okay, now let me erase that. Okay, let me erase what's on there and show you something else. Okay, I'm actually gonna, you know what? I'm gonna leave that one, that arc highlighted. Okay, that's a 40-degree arc. As we look at that 40-degree arc, what do you notice now that I'm highlighting in blue? This right here, what I just highlighted, is the central angle of that arc. Y'all, the central angle of the arc and the measure of the arc are the same thing. And look at this. It's angle C that we're looking for. If that's a 40-degree arc, it's a 40-degree angle. Moving on now to question number two. What is the equation of the circle with center -2, +3 that passes through the point 4, 5? Okay, if we're looking for the equation of a circle with a given center, that part of it is pretty easy. Okay, when we see a center of -2 and +3, we put that into the equation. It becomes x plus 2 squared, and it becomes y minus 3 squared. Okay, the left side of the equation is pretty simple. But why in the world would the right side of this equation be equal to 40? Okay, let's talk about it. Okay, as we look at, not that, okay, as we look at the 2 points that are given to us right here, we've got the point 2, 3, and we've got the point 4, 5. If we're looking for the distance between those 2 points, okay, that distance is the same thing as our radius because it's the center point and a point that's actually on the circle. Okay, the distance between the center and a point that's on the circle is the radius. So if we're talking about the radius, we're talking about the distance, and we know the distance formula. It's a big old ugly looking square root, right? It's going to be subtracting the x values and squared, and then subtract the y values and square it. And it ends up being a whole mess of stuff, okay, where r equals a square root. That becomes -6, so it's 36. Becomes -2, so it's 4. R equals the square root of 40. That's the radius of this circle. So what that means is that if we had r squared, it's just 40. Okay, that's where this thing right here comes from. So that's your answer. Okay, because of our coordinates, we've got +2 and -3 in the equation, and because of that distance, we've got 40 on the other side of the equal sign. Going on now to look at question number 3. Okay, question number 3 requires a couple extra steps of thinking. Okay, so work with me here as I talk through it. It says that a team in science class placed a chalk mark on top of the wheel and rolled the wheel 3 times. Okay, so when you think about a wheel rolling, okay, when you think about a wheel that is rolling on the ground, what part of the wheel is actually touching the ground? Okay, the part of the wheel that's actually touching the ground is the outside of it. Okay, and so if you're measuring how far a wheel rolls, you're measuring how long is the outside of that wheel. When you talk about the outside of a circle, the way we called that before was always the circumference. Okay, so that what it's talking about is when it was rolled 3 times and then measured, that was measuring how long is 3 times the circumference. How long is 3 circumferences? Okay? So what that means is when we see this 94.25 right here, that is 3 times 2 pi r. It's 3 times the circumference. Okay? That circumference, that right there. Okay, so 3 times the circumference. That's what 2 pi r is. So we need to realize here that ultimately the goal is to find the area. And if that is the case, we have to be able to use the radius. Okay, so we use this 3 times the circumference. We simplify it down. That becomes 6 pi r when you multiply the 2 times 3. Well, y'all, if you're trying to get radius by itself, you got to divide by that 6 pi. Get that 6 pi out of there, and we find that our radius is equal to 5. Okay, this is not your final answer. This is going to become part of your final answer because your final answer is the area of that circle. If we're talking area, we're talking pi times the radius squared. Okay, so that means we've got pi times 5 squared, which is 25 pi. And if we're rounding to the nearest tenth, we're not keeping our answer in terms of pi. Rounding to the nearest tenth, it's going to be 78.5. Go on now to our next question. Find the value of x. This one's going to be a little bit quicker, a little bit easier, okay? As long as you can recognize that x in this diagram, x right here is the radius of the circle. You know what else is the radius of the circle? This line right there. That is also x. Okay, so we also, a couple of things we notice. Not only would the hypotenuse of this triangle that we drew be equal to x, we also notice that this line segment that's labeled 6 is perpendicular to the chord. So that means this side and that side are the same length. It splits that chord in half. So if we're talking about, let me draw this off by itself, okay? Without the whole rest of the diagram, what we have is a right triangle with 6 and 7 and x. Y'all, if we're just dealing with the side lengths of a right triangle, it's Pythagorean theorem. Easy peasy. A squared plus b squared, that's going to be 6 and 7. So 6 squared plus 7 squared. We add up 36 and 49 gives us 85. So if we just take the square root of that, that'll find us x. Again, we are finding to the nearest tenth. So we take that square root, we round it off at 9.2. Moving on right now, and we've got a formula already written on the board. How convenient is that? It's asking us to find the length of an arc. Okay, the arc that we're dealing with in this problem is ypx. All right, so this is going to be another one that ends up going pretty fast if you know that formula or if you can locate it in your notes. Okay, 2 pi r is the formula for circumference, and you multiply that times theta over 360. Okay, here's the thing, here's the extra step, the extra connection that you have to make is that theta right here, this is our theta, and that's not equal to 90 degrees. It's equal to 360 minus 90. It's 270 degrees. Okay, so when we plug in 2 pi r, it's that times 270 over 360. Okay, so 2 times pi times 12. That fraction simplifies down to 3/4. 24 pi times 3/4 gives us our answer of 18 pi. Now I believe we're on question number 6. Find the exact area of the shaded region, okay? So here's your hint. You're going to find the area of the whole sector. And then subtract the area of the triangle. Okay, area of that whole entire sector, that whole entire wedge. I'm talking about this entire outlined area. and then you subtract the part that's just the triangle. So subtract then this blue part, and you'll be left with just the pink shaded region. Okay, so here's how we do it. The sector area is pi r squared times that fraction, 90 over 360. Okay, your theta here is 90 degrees. So pi r squared is just pi times 8 squared. It becomes, when you simplify everything down, 16 pi is the area of the entire yellow outlined area. Okay, what we do now is we subtract the area of this triangle. The area of this triangle, the area of any triangle, is 1/2 base times height. So that's just 1/2 of 8 times 8, which is 64. So that half becomes 32. Okay, if we are subtracting area of the sector minus area of the triangle, it's just 16 pi minus 32. Leave those two things separately. Okay, leave those two things separate from each other. It becomes pretty easy to figure out. Moving on up, what is the value of x? This was directly out of topic 12, the last day of the notes, I believe it was, in topic 12. And here's what you need to remember on all of these weird problems that look kind of like this, okay? Part times whole equals part times whole. Here's what we mean by that. On each of these chords, we would say that 4 is the part on the outside, but the whole entire thing altogether would be a length of 18. On this one, x is the part that's on the outside, but the whole, here, let me undo that. X is the part that's on the outside. The whole entire thing altogether is 2x. Okay, so here's what that looks like. Part times whole, outside part times the whole thing is x times 2x. And on the other chord, the outside part, 4 times 18. Okay, simplifying stuff down as we go. X times 2x is 2x squared. 4 times 18 is 72. We want to eventually get x by itself. That's what this question is asking for. It wants us to find the value of x. Okay, so we need x by itself in this equation. We divide by 2. X squared equals 36. Oh my goodness. Suddenly, it is very easy to solve this thing, isn't it? X squared equals 36. Well, that means x is just 6. Go on to this next one. Finding the radian measure of an angle. This is from way back in topic 11. Okay, this is way on back there, but I know it's in your brain somewhere, okay? If you're converting from 250 degrees and it wants us to find the radian version of that, we start off with 250 degrees and we multiply it times pi over 180. This is in your notes. This is something you could write down on a formula sheet. However you want to keep track of this, 250 times pi over 180. And then what you do is you multiply in your calculator, excuse me. This right here is equal to 250 pi over 18, right? Okay, you multiply, you put that over 1, top times top, bottom times bottom. But that's not what we're worried about, okay? When you punch this into a calculator, do not type in pi. Do not type in the calculator. Don't put it. So that means all you're going to type in the calculator is 250 over 18. Over 180. That's what you're going to type into the calculator. And you're going to hit math, and you're going to hit frac. Okay, you're going to hit the math button on your calculator, and the first thing that pops up, frac, turns your answer into a fraction, turns into 25 over 18, and then when you reattach pi to your answer, it becomes 25 pi over 18. This last one is the quickest and easiest problem on either of our reviews. Find the circumference in terms of pi. Well, we know that the circumference is just equal to pi times diameter, right? Look at what it gave us in that diagram. It is the diameter. It's just 3.8 pi. Don't make that one too hard on yourself, all right? That's going to be all for our review. Best of luck to everyone on their DCA. Don't forget about your rewards and prizes that you will get depending on your grade for the DCA. Y'all have a good one.